Now, what is a kernel? Kernel is a central component of an OS that manages operations of computers and hardware. It basically manages operations of memory and CPU time, and it is a core component of an OS. Kernel acts as a bridge between applications and data processing performed at the hardware level using IPC, inter-process communication, and system calls. Right. So, what are different scheduling algorithms? I'll go through these in depth. So, I'll cover this in the next video. Right now, let's discuss all the other concepts. Right. Time sharing system is a logical extension of multi-programming. CPU performs many tasks by switches that are so frequent that user can interact with each program while it's running. A time-shared operating system allows multiple users to share computers simultaneously. Right. So, what problem we face in a computer system without an OS? Poor resource management, lack of UI, no file system, no networking, no IO devices, and error handling. Right. Now, what is FCFS? Explain it briefly. So, it is first come first serve. So, in this algorithm, the job that arrived first in the ready queue is allocated to the CPU. Job that arrived first, that is by first come first serve, is allocated to CPU, and then job that came second, and so on. It is a non-preemptive scheduling algorithm. That means that a process holds the CPU until it either terminates completely or performs input output. Thus, if a longer job has been assigned to the CPU, then many shorter jobs after it will have to wait, because we cannot take out the longer job until it completes completes or terminates or performs IO. Right. Now, RR scheduling algorithm, round robin, is basically used to schedule the process fairly for each job in a time slot, or quantum. So, a quantum is basically a time slot, right? And interrupting the job if it is not completed by then, the job comes after the other job which arrived in quantum, making scheduling fairly easy. So, it is also this is also a preemptive scheduling technique, right? This is a preemptive one because we can take out a process from the CPU in case it is a very long process and put a shorter one at that point. Now, it is cyclic in nature, so starvation does not occur. It is a variant of first come first served scheduling. No priority or special importance is given to any process or task, and it is also known as time slicing scheduling. Right. Now, moving on, what are the different RAID levels? So, RAID is basically redundant array of independent disks. Redundant, RAID, redundant array of independent disks, is a set of several physical disks, disk drives that the OS sees as a single logical unit. It played a significant role in narrowing the gap between increasingly fast processors and slow disk drives. So, it has different levels from level 0 to 6. Now, what is the banker's algorithm? It is a resource allocation and deadlock avoidance algorithm, right, that tests for safety by simulating the allocation for the predetermined maximum possible amounts of all resources, then makes an S-state check to test for possible activities before deciding whether allocation should be allowed to continue. Right. Now, we'll discuss the main differences between logical and physical address space. So, logical address is generated by CPU, while physical is located in memory unit. Logical address space is a set of all logical addresses generated by CPU in reference to a program. Physical address is a set of all physical addresses mapped to the corresponding logical addresses. Now, users can view the logical address of a program. Users can never view the physical address of program, and it is generated by CPU, while physical address is computed by the MMU. The user can use logical address to access physical address, but user can indirectly access physical address but not directly. Now, how does dynamic loading aid in better memory space usage or utilization? So, with dynamic loading, a routine is not loaded until it is called. This method is useful when large amounts of code are needed in order to handle infrequently occurring cases like error routines. Now, fragmentation. So, processes are stored and removed from memory, which makes free memory space, which is too little to even consider utilizing by different processes. Suppose that process is not ready to dispense to memory blocks since it has little size and memory hinder consistently staying unused is called fragmentation. So, it occurs during a dynamic memory allocation framework when free blocks are small, so it can't satisfy any request. Right. So, that's